The shaded region is bounded by the curve x minus 3 all squared plus y minus 4 all squared equals 4, and the line x equals 4. Show that the area of this region is given by the definite integral, the integral from 4 to a of 2 root 4 minus x minus 3 all squared, stating the value for a. So we know that the centre of the circle is at 3, 4. And we know that the radius is going to be the square root of 4, which is 2. That means that here is 5. We know that here is 4 because that line was x equals 4. And that tells us straight away that a is equal to 5. Now, if I draw a line through here horizontally, we have y minus 4 all squared is equal to 4 take away x minus 3 all squared. So y take away 4 is going to be plus or minus the square root of 4 minus x minus 3 squared, and therefore y is equal to 4 plus root 4 take away x minus 3 squared, or 4 take away the square root of 4 take away x minus 3 squared. The bottom part of the curve here is this one, and the top part is this one. Therefore, if we're integrating between two functions, we're going to do this function take away this function. So the area would be the integral from 4 to 5 of 4 plus the square root of 4 take away x minus 3 squared dx, take away the integral from 4 to 5 of 4 take away the square root of 4 take away x minus 3 squared dx. You could have put them in a single integral to start with. And so that is equal to 4 to 5, 4 plus the square root of 4 minus x minus 3 squared, take away 4 plus the square root of 4 take away x minus 3 squared. And tidying that gives us twice the integral from 4 to 5 of the square root of 4 take away x minus 3 all squared dx as required. So we now want to use the substitution x minus 3 equals 2 sine theta to determine the exact value for the area of the shaded region. So let's start with the limits first. So let's just change colour. When x is equal to 5, we get 2, so that's 5 take away 3, is equal to 2 sine theta. That means sine theta is 1, which means theta is pi by 2. When x is equal to 4, that gives us 1 equals 2 sine theta. Sine theta is a half, and therefore theta equals pi by 6. dx d theta would be equal to 2 cos theta. So we can replace dx with 2 cos theta d theta. So it was supposed to be a theta just there. Okay, so I think we're in a position to do the substitution. So a is going to be twice the integral from pi by 6 to pi by 2 of the square root of 4 take away 2 sine theta squared, and then the dx is 2 cos theta d theta. Okay, let's see how we can go with that. So that is going to be twice the integral from pi by 6 to pi by 2 of the square root of 4 take away 4 sine squared theta, 2 cos theta d theta. And that's going to be twice the integral from pi by 6 to pi by 2 of the square root of 4 cos squared theta. And that's just using sine squared plus cos squared is 1. 2 cos theta d theta. And so the square root of 4 cos squared theta is, of course, 2 cos theta. And so we've got twice the integral from pi by 6 to pi by 2 of 2 cos theta times 2 cos theta, which is 4 cos squared theta d theta. And so we could write that as 8 times the integral from pi by 6 to pi by 2 of cos squared theta d theta. And now we can use that cos 2 theta is equal to 2 cos squared theta take away 1. So 2 cos squared theta would be cos 2 theta plus 1. And cos squared theta is cos 2 theta plus 1 divided by 2. So substituting in, that's 8 times the integral from pi by 6 to pi by 2 of cos 2 theta plus 1 divided by 2 d theta. So that's 4 times the integral from pi by 6 to pi by 2 of cos 2 theta plus 1 d theta. So that's 4 theta plus sine 2 theta divided by 2, going from pi by 6 to pi by 2. Okay, so that's 4. Using the top limit, we get pi by 2 plus sine pi divided by 2. And then using the bottom limit, we get pi by 6 plus sine pi by 3 divided by 2. So that is 2 pi. Sine of pi is 0, so that's going to go. Take away 2 pi by 3. Take away sine of pi by 3 is root 3 over 2, so that's root 3 over 4. Hold on a second. Yes, root 3 over 4, but of course 4 times that because of the 4 from here. And so what we have is 4 pi by 3, take away. 4's cancel here, root 3.